Welcome to section 3.3, finding zeros of polynomials. This is part 1. We're going to review and talk about factoring. So if we want to find the zeros of x squared minus 5x minus 36, this is a pretty typical quadratic that we have factored many times before. We find what multiplies to get negative 36 and what adds to get negative 5. So those numbers would be negative 9 and positive 4. So we'd say x minus 9 times x plus 4. And then we set each of those parentheses equal to 0 and solve. So we set this first one equal to 0. We get x equals 9. The second one equal to 0. We get x equals negative 4. So we find out that the zeros of that quadratic are 9 and negative 4. Now we want to apply that to number 1, factoring to find the zeros of x to the 4th minus 5x squared minus 36. Notice all the numbers are the same, the coefficients as our warm-up. The only thing that's different are the exponents. Well, we factor it very, very similarly. You still want to know what multiplies to get negative 36 and adds to get negative 5. It's still negative 9 and 4. But when you go to put it in the parentheses, instead of just x minus 9, we would have x squared minus 9. And instead of x plus 4, we'd have x squared plus 4. This is because if we take these first two x squareds, they have to multiply to equal x to the 4th. Then we have some more factoring we can do. Here we have a difference of squares. X squared minus 9 factors to x minus 3 times x plus 3. X squared plus 4 does not factor, so that would stay as x squared plus 4. Then we would take each of those and set them equal to 0. So we set this first one equal to 0, we get 3. Next one, we get negative 3. And you have to be careful with this x squared plus 4. When we set it equal to 0, you actually want to solve it out. So subtract the 4, because some people think that they know the answer without solving, and they get the wrong answer. Because notice how we get a negative 4. When you take the square root of a negative number, that goes back to when we have imaginaries. So we have plus or minus because we took the square root, and then it's not just 2, it's 2i. So these two zeros represent our two x-intercepts. We'd have x-intercepts at 3, 0 and negative 3, 0. And then we'd have some imaginary zeros at 2i and negative 2i. As a reminder, you always have as many zeros as your degree. So since we had a degree of 4, we have 4 zeros here. 3, negative 3, 2i, and negative 2i. All right, let's take a look at number 2. Number 2 is a cubic, and it is 4 terms. As a review, we always do grouping, factoring by grouping when you have 4 terms. So you're going to group the first two together, group the second two, figure out what your GCF is in those first two, x squared. We have 3x minus 2. And the next two, it's negative 9. So we have 3x minus 2. So we end up having 3x minus 2 times x squared minus 9. Just like on the previous problem, x squared minus 9 can factor even more. So we have 3x minus 2 times x minus 3 times x plus 3. We already solved these before, so we know that's going to give us a positive 3 and a negative 3. But we have to set 3x minus 2 equal to 0 as well. We would add the 2 and divide by 3. So it would be a positive 2/3. And again, check, you have a cubic here, so we'd have 3 zeros, and then we have 3 zeros as our answer. All right. Now we're going to kind of go backwards a little bit. They're giving us the zeros, and we are going to write the equation. So it's telling us that we have a 0 of 3 and 4i. So a 0 of 3 would come from a factor of x minus 3. 4i would be x minus 4i. And anytime you have one imaginary number, you also have its conjugate. So we know that negative 4i would also be a 0. Don't forget that one. So notice here we have to have a third degree, so we need 3 zeros. So if you leave out that other 4i, you only have 2 zeros. You'd end up with a quadratic instead of a cubic. So when you see one imaginary, make sure you put in the other imaginary. Now we're going to multiply. So I'm going to multiply these two conjugates first. So I get x squared minus 4ix plus 4ix minus 16i squared. The middle terms would equal 0. I squared, if you recall, equals -1. So negative 16 times -1. We end up with an x squared plus 16. Then we drop down the x minus 3 from up above, and we multiply that out. X cubed plus 16x minus 3x squared minus 48. And we want to make it an equation, so in our final answer we're going to add in a y equals. We also want it to be in standard form, so it has to be in descending order of exponents. So our biggest exponent goes first, and then the next biggest, so on and so forth. So now we have a third degree polynomial equation in standard form.